How do small inductors transfer power in DC-DC converters? Have you ever wondered how small inductors play a role in transferring power within DC-DC converters? Let's break it down in a simple way. Small inductors are essential components in these converters, and they work by temporarily storing energy in their magnetic field. When current flows through the inductor, it builds up energy. Then, when the current path is interrupted, the inductor releases that stored energy to the output circuit. This process allows for the conversion of one direct current voltage level to another efficiently. Now let's get into the details. An inductor has a property called self-induction, which means it resists changes in current flow. When the switch, often a metal oxide semiconductor field effect transistor, is closed, current flows through the inductor, and energy is stored in its magnetic field. When the switch opens, the inductor opposes the sudden drop in current by releasing the stored energy. This energy then flows through other components, like diodes and capacitors, to the output load. This transfer of energy helps regulate the output voltage at a different level than the input voltage. In different types of switching DC-DC converters, such as boost, buck, or single-ended primary inductor converter topologies, the inductor plays a central role. In a boost converter, the inductor gathers energy while the switch is on and then delivers that energy to the load when the switch is off, effectively increasing the voltage. On the other hand, in a buck converter, the inductor smooths the current to the load by storing energy when the switch is on and releasing it when off, which decreases the voltage. For a single-ended primary inductor converter, two inductors and a coupling capacitor work together to transfer energy. This setup allows the output voltage to be either higher or lower than the input voltage while keeping the same polarity. The size and characteristics of the inductor significantly affect the performance of the converter. Small inductors designed for power applications minimize losses and support high currents while remaining compact. Their inductance value and current rating are optimized to balance energy storage and minimize ripple current. This balance improves the stability of the output voltage. In summary, small inductors in DC-DC converters act as energy storage elements. They enable efficient power transfer through controlled switching, shaping the voltage and current delivered to the load. This is especially important in power electronic systems, including renewable energy converters and battery-powered devices, where efficiency and reliability are key.